This is a pretty hard question and very easy to just go down the wrong path. In fact, the particular type of knowledge you're expected to know regarding this question is about the medians of a triangle and some absolutely like niche little properties that you don't learn about typically in maths lessons, but you need to be familiar with, for these sorts of competitions. And of course, there's loads of maths outside of school that is just there to be learned. And doing questions like this, hey, I'm going to teach you a little bit about it if you didn't know about it before. Um, so S and T are midpoints, and then we're connecting them to the opposite vertices, and that actually makes TR and SQ what we call medians. And there's a very specific property about medians in that they split each other into the ratio 2 to 1. So this will be worth 2 parts, and this length here will be worth 1 part. We're assuming the diagram is drawn reasonably accurately, or we can just see that this point here is longer than the other one. I'm just going to label this point capital X. Now, capital X is actually called the centroid. Okay, we don't need that for this video, but you might see it in the future. And it actually has some interesting properties. For example, if this was a uniform kind of sort of prism that you were like hanging up, then if you hung it up, then actually the centroid would end up being directly below the string. It's kind of the center of mass. I think I'm right in saying that. All right, now we're well on our way with this little fact. Without it, we are stuck unless you can prove it all in the question. But with it, we're well on our way because we know that QS is 8. So I can do 8 divided by 3, and that is going to be what 1 part is. And so, yeah, this length is 8 over 3, and this length is going to be twice that. It's going to be 16 over 3. And now I can work out the area of this green triangle here because remember TR, we're told, is 12. I don't need to split that up or anything. So I've got a right angle here, and therefore triangle QTR, the area is going to be a half times the base times our height, which is 16 over 3. Well, a half of 12 is 6, and then 6 divided by 3 is 2. It's 2 times 16, we're going to get 32. But here's the thing, because QT and TP are the same length, then actually if we rotated this triangle, we'd see that they must have the same area. Let me just do that to convince you. Rotate it around like this. So we found out this area. Wait, what did I have it in? I had it in green. But now if we compare the two triangles, we see that, look, that base, I didn't quite rotate it enough, but it's enough. That base and that base, they're the same. And the perpendicular heights of both of these triangles is the same. This one in purple here, same perpendicular height. So what I'm saying is that the purple triangle here also has an area of 32. And therefore the overall area is going to be 64. Wow. Now, you might be, and you should be saying to yourself, why is that 2 to 1? Where did that come from? And so we definitely want to look into that, don't we? We want to develop our understanding of medians a little bit more, not just accept that that is a fact we need to learn. Let's develop our understanding because I think it will help us remember it. So I'm back to this triangle. Okay, forget the question now. Just a triangle with the medians. It turns out that if I draw the other median from QR, then they will all intersect at the same point. This centroid. Actually, let me do it like that. I'm not going to prove that, but it is the case. And the next thing I'm going to do is actually, okay, so I'm trying to prove this 2 to 1 ratio, but the next thing I'm actually going to prove is that all these triangles have the same area, these little triangles. All 6 of them have the same area, which is pretty amazing. Um, I mean, they kind of look like they do, but we don't really know that for sure. So what we can do, first of all, is say, if this one here is x, then this also must be x. And that's using the same argument that I used before, because look, these have the same base, and they're going to have the same perpendicular height. That's x, x. And similarly, okay, this one's maybe a little bit easier to see. They have the same base and the same perpendicular heights here. So y and y. At the moment, we don't know that they're all the same. That's what we're trying to prove. And then we've got z and z. Okay, but what I can then do is look at the bottom parts, just like I did before, and say that that must equal the top part and area, because now I'm like splitting the big triangle into two. Again, same base, same perpendicular heights. So it must be that x plus 2y equals x plus 2z. That means that y is equal to z. We've just shown it. And you can make a similar argument for to show the other ones. I might as well keep going. So look, it must be that this green area is the same as this purple area. So 2x plus y is 2z plus y. And that shows that x is equal to z. And because y is equal to z and x is equal to z, they're all equal to one another. So actually, I can draw a new diagram where they're all the same. That is a really nice proof, I think. I mean, maybe this is, I don't know who teaches this, but I think it should be. It's just like such a nice result. Right, finally, we just need to show that, about the medians splitting each other into the ratio 2 to 1. So this is the very last bit. So I'm just going to focus on this median here, but we could apply the same argument to any of them. In fact, I'm going to focus on the red triangle. So the median is the base, and maybe I'm just going to draw it out away from everything else. Could look a little bit like this. And I'm just going to draw some of the lines on. So we've got the centroid here. I'm going to call that capital X, and then that line coming down. And then another line coming across like that, the T, and I've got P here. So this triangle is going to have, yeah, they've each got the same area. And the thing is, if I focus on, okay, this green triangle here, then I've got some sort of base and I've got a height. So I could say that x is equal to a half base times height. But if I now focus on the purple triangle, and that's these two all together, then they're going to have some other base. Maybe I'll call it capital B. And this area would be 2x is equal to a half times capital B times the same height. So the green triangle is just half times little b times h. I've introduced this height. It's the perpendicular height of the triangle, but it is the same perpendicular height of the purple triangle. So it's a half times capital B times h, and that's 2x. It's twice as much. So we can substitute x into here, which will give me 2 times a half times base times height equals a half. Capital BH. I can cancel out those. I can divide through by h, and I see that b is equal to a half capital B, or capital B is 2b. And what I've just shown, therefore, is that the ratio between the lengths of the median compared to the centroid is 2b to b, so it's 2 to 1. Oh, okay, that took quite a bit to show it. That is the fact that we are expected to use in this question. So because they're in the ratio 2 to 1, that's how I knew to divide the 8 by the 3, to split it into these three parts. We've got 8 over 3 here, we doubled it to get 16 over 3 here, and then the question came together. But it's really important to understand where that came from, but it is a little fact to learn. Well done with this question.